Welcome to Dakota Prep Question Walkthrough. What question are we doing? Oh, look, motor bank feeder supply. Also very exciting. I don't know about you guys, but I wake up every morning and I think to myself, you know what I want to do today? I want to do some Canadian electrical code questions relating to motor bank feeder supply. And look at, here I am, living my best life. All right. What is it asking for? What do we have? What do we need? This is our mantra for every single C of Q question. What size of R90 XLPE is required to feed a three-phase 575 skim squirrel cage induction motor bank of 25 horses, 50 horses, and 40 horsey, but the 40 horsey is intermittent duty, 15-minute rating. So what is it asking for? This is asking for the size of an R90 to feed. So it's asking for conductor size. Which conductor? It's asking for feeder or supply. Feeder or supply. And the code for this is 28104. Ta-da! There we go. Okay. Now, what do we have? We've got our motor info. Beautiful. What do we need? As always, we need our flaws. You do not have to do this. But me and my little brain, I like drawing things out. I find it makes it significantly easier to keep track of what I'm doing. And in the C of Q, even though it's now done on a computer, you are given a scrap piece of paper. So I'm just going to make him happy and give him a little bit of hair. There we go. When it comes to feeder supply, we're talking about this very specifically. So this is our main overcurrent. This is our splitter. And then this right here is what we're trying to size. Now, guess what? Fun fact, 4-006 actually applies to that. So we need to keep that in mind. Also, let's take a look and figure out which of the tables we're going to be using when it comes to sizing. Does this question mention copper or aluminum? It doesn't, so we assume copper. Does it mention free air or conduit? It doesn't, so we assume conduit. So we know right off the bat, we are going to be going to table 2. What column we're going to be using for the Celsiuses is all very much dependent on our 4-006. All right, so we have our first motor here, 1, 2, 3. Our first motor, which is 25 horses. Our second motor, which is 50 horses, and our third motor, which is 40 horses. Because this is three-phase, we're going to head on over to table 44. Let's change the color here. Table 44. We look in our squirrel cage right there, and then we just find our 575, and then we just pop off. There we go. So our 25 horsey is 25 amp FLA. Our 50 horsey is 52 amp FLA, and our 40 horsey is 41 amp FLA. Beautiful. Is there any other information we require? Why, yes. When we have a conductor, what else do we need to know? We need to know our duty. Well, it states that our 25 and our 50 are both continuous. Well, it doesn't state their continuous duty, but because it doesn't say anything at all, we assume continuous duty. And that is basically codes. We don't really assume it. Code tells us that. But our 40, our 40 is intermittent duty, 15-minute rating. That's fancy. So where do we go for that? We head over to table 27. Wacha. And we take a look for our intermittent duty, 15-minute rating, and it tells us our multiplier is 85%. Awesome. So we're going to swing back here again. This code specifically tells us that we take the continuous duty motors. We take the largest FLA for our continuous duty motors, multiply it by 125%, and then add all other FLAs. That is for continuous duty. So we'll do that first. So our largest FLA in this case for continuous duty is 52 amps times 125%. And we're going to add all other continuous duty FLAs, which is 27. And that gives us a grand total of 92 amps. Code then says we then add all other continuous duty calculated FLAs. So we have to be careful with the wording. This here, our 41 amps, is our actual FLA. It's telling us we have to add our calculated FLA. In order to get our calculated FLA, we take our 41 and we multiply it by that duty multiplier times 85%. So that gives us 34.85. Ooh, little dot there. So because code says we now add on our calculated FLAs, this is now our calculated FLA for motor 3. So we're going to add that to our 92. That is going to give us a grand total of 126.85 amperes. All right, so earlier we decided we were going to be using table 2. Keeping in mind 4-006, 126.85 is obviously higher than 100 amps, so we're going to be using our 75-degree column. We head over to table 2, use our 75-degree column. Hold on, it's right here. And it shows us that we are going to go all the way up to a number 1. A number 1 can hold 130 amps. So we are going to be using a number 1 Augie for this question. So what size of R90 XLPE is required to feed blah, 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 blah? It will be a 1-aught. Now, again, friendly reminder, when we get these questions, what is it asking for? Conductor. Which conductor? Because especially when it comes to motors, which conductor? You could have your branch circuit, your motor supply, your secondary resistor supply, your secondary controller supply, your feeder supply. You have to pay attention to which part of the motor conductor it's asking for. The only other thing we care about at that point is our duty. So please, 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 conductor, which conductor, what's my duty? Anyway, there you go. Ta-da!